on the road. All right, so far in Unit 3, we have learned how to define sine and cosine in standard position using the unit circle, correct? Yes. Functions. Fine.
That's crazy.
Yeah. Why are you insulting my creativity?
Insulting yours.
No. Anyways, moving on. What we're going to do is talk about the graphical representation of these sinusoidal functions. Okay. So, click. So considering that a function can be our next test, I can't tell you off the top of my head, but if you click on the live calendar link on your modules page, it's there. Yeah. F of theta is the same way of saying f of x, right? Theta is our unknown when we're referring to angles. Okay. So we're going to basically create a model representing how sine changes as we rotate around the unit circle. Does that make sense? Okay, because a function is just a representation of a pattern, correct? And there is a pattern that exists as you rotate around the unit circle. So let's analyze that pattern. So here's our unit circle. And on our unit circle, we currently have our 30, 60, 90s listed, correct? And so looking here, we're going to go through and talk about what is the sine at each one of these points, okay? So starting at pi over 6, what is the sine at pi over 6? Which coordinate is sine? It's 1/2 because which coordinate is sine? Your y. Your y coordinate is your sine. No. Sine is always your y. Your y coordinate is your value of your sine. So when I'm asking what is the sine at pi over 6, we're looking at the y coordinate at pi over 6, correct? So sine of pi over 6 is 1/2. Sine at pi over 3 is? Sine at pi over 2? Sine at 2 pi over 3? Sine of 5 pi over 6? Sine of pi? Sine of 7 pi over 6? Sine of 4 pi over 3? Sine of 3 pi over 2? Sine of 5 pi over 3? Sine of 11 pi over 6? And sine of 2 pi. 0. Okay, so again, all I did was go around the unit circle and identify the sines, correct? All right, now when I want to graph these, when I'm graphing, I'm not going to utilize the square root ones because they're not easy to graph, right? However, we're going to use our halves and our ones and our zeros, okay? So we're going to graph pi over 6 at 1/2, pi over 2 at 1, 5 pi over 6 at 1/2, 3 pi over 2 at -1, 11 pi over 6 at -1/2, and 2 pi, and I didn't mean to skip pi, at 0. So these are the points that we're going to plot on our coordinate plane. So we're taking our unit circle and we're plotting the values on a coordinate plane. So starting here, this is 0. Does that make sense? At 0, what is sine? At 0, sine is 0. My next is at pi over 6. At pi over 6, we're at 1/2. I'm going to skip pi over 3. I'm going to go to pi over 2, and it's at 1. I'm going to skip 2 pi over 3, and I'm going to go to pi, and pi is at, I'm sorry, 5 pi over 6 is at 1/2. I'm going to go to pi, and it's back at 0. I'm going to go to 7 pi over 6, and it's at -1/2. I'm going to skip 4 pi over 3, and I'm going to go to 3 pi over 2, which is at -1. And then I'm going to go to 11 pi over 6, which is at -1/2. I'm going to come back to 2 pi. What you just created, my friend, is our sine wave. Pretend that this is curvaceous. Use your imagination. Okay, this is our sine wave. I call it the snake function. I know, been calling it that for a while now. All right, that means that this function, this is the pattern that repeats every cycle, right? And that's every cycle means that I've gone around that unit circle. Does that make sense? So from 0 to 2 pi, I'm going, get it. I can't even think about being it as a body. But that's what's happening every cycle, which means I'm going around that unit circle. This is the pattern that repeats. Yes? So we're going to talk about the properties of this. The main points that you want to remember are your zeros and your ones. If you remember your zeros and ones, then it makes it easy for you to reproduce this graph. So here is an intercept. Here is my max. Here is an intercept. Here's my min. Here's an intercept. Those are going to be your 5 key points for graphing and translating sine function. Does that make sense? This is a positive sine function because I rotate it counterclockwise around the unit circle. All right, so let's talk about its properties. The properties of the sine function, f theta sine theta. It has an amplitude. What your amplitude is describing your distance from the middle of your graph to your midline. Your midline is the halfway point of your graph. Because this is a odd function, it's centered around the origin. It has rotational symmetry. My midline here is the x-axis. So that's my midline. My midline is at y equals 0. Your amplitude is your distance from your max to your midline, and that is 1. Or from your minimum to your midline, which is also just 1. Okay, to find it algebraically, all you're doing is find the halfway point between your max and your min. Does that make sense? So if you're looking for the midline, it's the halfway point between your max and your min. All right. Your amplitude is the distance from the midline to the max or to the minimum. Your period is how long did it take for your cycle to start and finish. Okay. So it took us from 0 to 2 pi. So our period is 2 pi. Your frequency is the reciprocal of your period. So if my period is 2 pi, then my frequency is 1 over 2 pi. This is a oscillating function, so your concavity is changing periodically. So it oscillates between being concave down and concave up. How do we feel about the sine function? Yeah? Doable? What we're going to add here, the domain and range. The domain of your sine function is all real numbers. It goes from negative infinity to positive infinity. And your range of your sine function goes from -1 to +1. Got it? Questions, comments, concerns? We just talked about sine. What comes after sine? Cosine. You're so smart. There we go. So now we're going to analyze our x values. And that's going to tell us our cosine at our points. Okay. So going through it really quick. Cosine of pi over 6. What do I get? Cosine at pi over 3. 1/2. Cosine at pi over 2. Cosine at 2 pi over 3. Cosine at 5 pi over 6. cosine at pi, cosine at 7 pi over 6, cosine at 4 pi over 3, cosine at 3 pi over 2, cosine at 5 pi over 3, cosine at 11 pi over 6, and cosine at 0 and 2 pi. Okay? So again, graphing wise, not that they don't matter, but we're just going to focus on our halves, our zeros, and our ones. So we're looking at do, 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 and do. Okay? So this time, 0 starts at 1. And then we're going to go to pi over 3, and pi over 3 is a half. We're going to go to pi over 2, which is 0. We're going to go to 2 pi over 3, which is negative half. We're going to go to pi, which is at negative 1. We're going to go to 4 pi over 3, which is at negative 1 half. 3 pi over 2, which is at 0. And we're going to go to 5 pi over 3, which is at a half. And we're going to come to 2 pi, which is back at 1. And again, you're going to pretend that this is the most curvaceous graph you've ever seen. Boom. Thank you. Okay. This is our cosine function, and we call it the cup. Do you see why I call it a cup?
I can see it.
Okay, call it.
The rock.
Okay, call it whatever you want to call it. I call it a cup. The cups at doctor's office where they give you the little tiny cup, little cone cup. Oh my gosh. All right. So essentially what you're trying to pay attention to is that a sine function creates the snake model, right? The cosine function creates the cup model. When you are looking for your key points for your parent function, you're looking for where your max intercepts and your mins. So for this function, we have a max at 0, an x-intercept at pi over 2, a min at pi, an x-intercept at 3 pi over 2, and a max at 2 pi. Those are our 5 key points for the cosine function. Okay, we're going to talk about the properties of the cosine function. The properties of the cosine function are the same properties as the sine function. Okay, your midline is still the same thing. Your midline is still at y equals 0. The amplitude is the distance from your midline to your maximum and your minimum, max or your minimum. Your period is how long does it start? How long does it take to start and finish? I start at 0 and I finish at 2 pi. So my period is 2 pi. Your frequency is the reciprocal of your period. My period is 2 pi, so my frequency is 1 over 2 pi. And it oscillates as well between being concave down and concave up. Okay, do we see that? This piece is concave down. This piece is concave down, and it keeps going. The domain is all real numbers. It goes from negative infinity to positive infinity, and your range is based off your maximum and your minimum. Your minimum is -1, and your max is 1. Okay. From seeing these, what that tells us is that these two functions are interchangeable. That's why they're called together sinusoidal functions. So your sine and cosine functions are part of the sinusoidal function family. Okay. It's any function that involves additive or transforming the sine function. Okay. The cosine function is a transformation of a sine function. Does that make sense? What makes it a transformation is that we're moving our starting value. That's it. Just where you're looking at it is changing. So sine and cosine are both sinusoidal functions. Cosine, any cosine function can be modeled by this of a sine function. Okay. Just because depending on where you're looking at on a sine or cosine graph, you can either see a snake or a cup. Does that make sense? So it just depends on where you're looking at in that window, okay? No, we're going to go over questions that you would get for the most part. So starting here, like just describing what's the period, the frequency, the midline, the amplitude. The reason why we are asked these things, because these things aren't going to change, whether it's sine or cosine. Does that make sense? They're going to stay what they are. All right. So let's begin. It says here that there are two periods of a sinusoidal function graph shown in the figure above. Find the period, the frequency, the amplitude, and the midline for the graph, right? So the first thing we want to decide is where are we starting and stopping? Are we analyzing it as a cosine function? Are we analyzing it as a sine function? I personally start near the origin and see what happens. So I'm starting at the origin, and I see that a snake is forming. Your paper printed weird, so just open it and turn it upside down. Yeah, I know. I lost the battle with the copier. So let me highlight. So we have, so that's 1. Huh? The period is going to be pi. So how long did it take me? Pi. Your frequency is the reciprocal of your period. Frequency equals 1 over your period. So therefore, this is 1 over pi. Easy enough? Mm-hmm. Your midline is the average between your max and your min. So our max is at 6, our min is at 0. So we have 6 plus 0 divided by 2, which is 3. So our midline is at y equals 3. Your amplitude is your max minus your midline. So your amplitude is your max minus your midline. So this would just simply be 6 minus 3, which is 3. How do we feel about analyzing so far? Still with me? Are you willing to try on your own? You're about to do example number 2. Okay, example number 2. It says there are several periods of a sinusoidal function are shown in the figure. Find the period, frequency, amplitude, and midline. Go. So decide which pattern are you analyzing, and it doesn't matter because everyone, no matter where everyone chooses, these 4 things are going to be the same. All right. So again, I always like to try to start near the origin, but do you have to start near the origin? No, you do not. That's just my personal preference. So for me, I started near the origin and I decided to follow the cup. Do you see the cup? Did you have to start near the origin? No, you could have started wherever you wanted. But I try to start near the origin, and if it doesn't work from the origin, then I work my way towards the right, and that's just how my brain works. So from here, I see that my cup started at 0 and it ended at pi over 2, which meant that my period is pi over 2. Okay, remember your frequency is the reciprocal of that. So if I have pi over 2, that means my frequency is 1 pi over 2, which is 2 over pi once you simplify it. Your midline, so again, define your midline. Your midline is the average between your max and your min. So my max is at 3, my min is at -1, and I'm going to find the average between these 4. Between these 2, and that puts me at what? 1. 2 divided by 2 is 1. So my midline is at y equals 1. Yes? Your amplitude is your max or your min, your max minus your midline, or your midline minus your min. Does it matter which way you do it? No. So I'm going to do max minus mid, which leads me to 3 minus 1, which equals 2. How we do? Easy? All right. So this is when we're given the graph to analyze. How do you think it's going to change when we're not given the graph? you can make a graph, but you got to pay attention to the coordinates, okay? So it says here, the sinusoidal function has a maximum at the point pi 8. The first minimum after reaching this maximum value occurs at the point 3 pi negative 2. Find the period, frequency, amplitude, and midline of this graph, okay? So I have a max at 3 pi over negative 2 and a min from, what was that? 3 pi negative 2. So when you're looking at this, between either one of our points, our max and our min, those are our half of our cycle, right? It is not a full period. So if I'm giving the max value and the min value and where they take place, I'm going back really quick to show you what I mean. So here's my max, here's my min. That's only half of my period. Does that make sense?
Yeah.
Okay, so if they tell me my max and tell me my min, that's not my full period. That's only giving me half of my period. So I have to find that distance and double it. Does that make sense? So we're going to find that distance and double it in order to calculate our full period. Okay? So let's go back to this problem using our words. When you're analyzing the period, you are using your x values, how your x is changing. Make sense? When you're looking at your midline and amplitude, that's vertical motion, correct? And because that's vertical, we're analyzing it based off of our y values. Got it? Period is horizontal, which are your x's, and midline and amplitude are vertical, which are our y's. So to find our period, we're going to look at our x values. Okay? So it starts, our max is at pi, and our minimum is at 3 pi over 2. So to find this distance, so we have 3 pi minus pi puts us at 2 pi. Remember, this is only half of our period. So to find our full period, it's going to equal 2 pi times 2. So our full period is 4 pi. Right here? Oh, okay. All right. So again, we talked about our maximum and our minimum. That is only half of our period. So when we find that distance, we have to double it to find our full period. Okay. Next is your frequency. Your frequency is the reciprocal of your period. So it just becomes 1 over 4 pi. Now we're analyzing our midline. The midline is the average between your max and your min value, right? So midline is your max plus your min divided by 2 because we're looking for the average, correct? So my max value is 8. My min value is negative 2. And we're dividing it by 2. And therefore, our midline is at y equals 3. Yes? Your amplitude it can either be found by your max minus your mid or your mid minus your min. Does it matter which one you do? No, it does not. So our max value is 8. Our mid value is 3. So therefore our amp equals 5. Oh. Okay, how do we feel? We survived? Yes.
So why is it max and why is it mid and then mid